Hi everyone. So in this video we are going to discuss a few questions related to impulse and change in momentum. Okay. So this is first question. A ball of 0.2 kg mass hits a wall with a velocity of 25 meter per second at an angle of 45 degree. Okay. If the ball rebounds at 90 degree to the direction of incidence, calculate the magnitude of change in momentum of the ball. Okay, so if you wish you can pause the video and try this question on your own, and then you can verify with my solution. Okay, acha, now so we have a wall. So this is the wall. Okay, and the ball is incident at an angle of 45 degree. That means this is normal to the wall. Okay, and the ball is coming like this. This angle is 45 degree. 45 degree. Okay, now the ball rebounds at 90 degree to the direction of incidence. So that means the ball rebounds in this direction, and this total angle is 90 degree. Okay, this total angle is 90 degree. Angle of incidence, it is already given, it is 45 degree. So that means the angle formed with the normal, this is the normal, so angle formed with the normal, this angle will also be 45 degree. Okay, so this is also 45 degree. Acha, now we have to find the change in momentum. Okay, now mass is given. Now let us take the mass as m and velocity as v. Okay, now calculate the change in momentum. Now see, the ball is coming like this, it is this direction, so this is mv, momentum is mv. Okay, now let us take this angle to be theta, so here theta is 45 degree. Okay, so I'm extending the normal in the opposite direction, this normal. Okay, now this angle is theta, so that means this angle is also theta. Okay, so if we resolve this momentum, this component will be mv cos theta, and this will be mv sin theta. Okay, so that means I can write, if we take this direction as x-axis, positive x-axis, and this direction as positive y-axis, then I can write the initial momentum pi. It is equal to mv cos theta I cap plus mv sin theta minus j cap. Why minus j cap? Because it is in the downward direction, mv sin theta. Okay, so this is the initial momentum. Okay, pi. Now what about the final momentum? Final momentum means after rebouncing. Okay, so it is going in this direction, so this is mv, this is theta, so that means component in this direction, it will be mv cos theta, and component in the downward direction, it will be mv sin theta. Okay, so I can write the final momentum pf, it is equal to mv cos theta minus I cap because this is in negative x-axis direction, then plus mv sin theta minus j cap. Okay, this component, it is in downward direction. Okay, so minus j cap direction. Okay, acha, so we have the initial momentum and we have the final momentum, and in the question it is asked calculate the magnitude of change in momentum. Okay, so change in momentum, that means delta p. Okay, so delta p, it is equal to final momentum minus initial momentum. Okay, so now if you subtract final momentum minus initial momentum, so that means this initial momentum will put a negative sign here, and this will become positive, and then we can add these two, isn't it? So if you add this mv sine theta component, this cancels out, and then we are left with the cos component. So delta p, it is equal to minus twice mv cos theta I cap. Okay, now we have to write the magnitude of the change in momentum. So it will be equal to twice mv cos theta. Okay, mass is given, speed velocity is given, theta is 45 degree. So if you substitute it and simplify, you will get the result as 5 root 2 kg meter per second. That is the unit of momentum. Okay, so this is 5 root 2 kg meter per second. Okay, so calculation that you can do it, but main thing is the understanding of the concept. Okay, so next question, we have a hammer of mass 1 kg moving with speed 6 meter per second strikes a wall and comes to rest in 0.1 second. Calculate an impulse of the force. So what is the impulse? Okay, average retarding force that stops the hammer, and third is average retardation of the hammer. Impulse of the force. See, impulse, it is the product of force and time. Impulse, it is equal to force into time. Okay, and it is also equal to change in momentum. So that is mv minus mu. Okay, the mass is 1 kg. Final velocity is 0 because it comes to rest, minus 1. Initial velocity is 6 meter per second. Okay, so this is equal to minus 6 Newton second. Okay, so this is the impulse. Okay, now next is average retarding force that stops the hammer. Okay, now average retarding force that stops the hammer. Now hammer stops in 0.1 second. 0.1 second. Okay, we have the information about impulse. Impulse is minus 6 Newton second. So that means average retarding force. Average retarding force F, it will be equal to 6 divided by force is, see, force is impulse divided by time. Okay, so impulse is 6 divided by 0.1. Okay, so that is equal to 60 Newton. Okay, now here you don't have to take the negative sign because already it is written that average retarding force. So it is 60 Newton. Okay, now average retardation of the hammer. Retardation, force is known. Force is equal to mass into acceleration. So acceleration will be equal to force divided by mass. So that is 60 divided by 1. So it is 60 meter per second square. Okay. So next question, we have a ball of mass 1 kg dropped from 9.8 meter height. Okay, 9.8 meter height strikes the ground and rebounds to a height of 4.9 meter. So if the time of contact between the ball and the ground is 0.1 second, find the impulse and average force acting on the ball. Okay, so suppose this is the ground. Okay, now the ball is dropped from a height h1. So it strikes the ground in the downward direction with velocity u. Okay, then it rebounds with velocity v, and then it reaches this height h2. Okay, So it rebounds with velocity v. Okay. Now we are asked to find the impulse. Okay. First find the impulse. Now basically, see, impulse, it is change in momentum. Impulse, it is equal to change in momentum. Change in momentum. So that is final momentum minus initial momentum. Okay. Now here, suppose the ball is of mass m. Mass is already given, but let it be m. Okay. So final momentum means after impact. So after impact, the ball is moving in the upward direction. Okay. So if we take the upward direction as positive, okay, and downward direction as negative, that means the final momentum will be positive. So it will be equal to mv minus, now here the ball just before impact, it is moving in the downward direction. So momentum will be in the downward direction. So that will be negative because we have taken the downward direction as negative. Okay. So it will be minus of minus mu. Okay. So that makes it mv plus mu. Okay. Now mass is given. We have to find the value of v and u. Okay. Now see, the ball falls from height h1. So obviously u, it will be equal to square root of 2g h1. Now similarly, the ball rises to a height h2. So v should be equal to square root of 2g h2. Okay. Now here in the question, h1 is given. h1 is how much? It is 9.8 meter. Okay. 9.8 meter, this one. Okay. And h2 is also given. h2 is how much? h2 is 4.9 meter. 4.9 meter. Okay. So we have to just plug in these values of h2 over here and h1 over here, and then get the value of v and u. Okay. So those values, if you substitute, okay, now this, see, this can be further written as m v plus u. Okay. V plus u, where v and u are these quantities. Okay. Now if you substitute and then calculate, you will get this to be 23.52 Newton second. 23.52 Newton second. Okay. So this is the impulse. Okay. Now it is also asked, what is the force? Okay. Now impulse, it is also equal to force into time. Impulse, it is equal to force into time. Okay. So that means force, it will be equal to impulse. So that is 23.52 divided by time. Time is 0.1. Okay. So this will be equal to how much? 235.2 Newton. Okay. 235.2 Newton. So this will be the value of the force.